So 2.2 part 2, we're still dealing with these functions. The first example that we're going to go over just tells us that a global data plan costs $25 a month for the first 100 megabytes and $20 for each additional 100 megabytes. With this, we're just going to give the function for it. So if we have the $25 that we're starting with, we're going to start with that $25. That's our initial fee. And that $20 for each additional is just going to be that 20 times x. So if we put this as a function of x, we would have f of x is equal to 20x plus 25. I'm really not worried about anything else with this. Like I said, biggest thing is putting it into that function. For your next page, we're looking at these word problems. We're going to skip that first one. Look at that second one, though. It says that for babysitting, Nicole charges a flat fee of $3. So that's your initial fee of the $3 plus $5 per hour. So that would be 5 per hour. So that's 5 times x. We're writing an equation for the cost C in hours after hours H of babysitting. So if this was just f is equal, or y is equal to 5x plus 3 to write it the way that they want us to, the total cost is going to equal the 5 times the amount of hours plus the initial cost of that $3. So here we can identify our slope and our y-intercept from this function because our slope is the coefficient of x, so that's 5. And our y-intercept b value is 3, so that gives us the y-intercept of 0, 3. It asks us how much money she will make if she babysits for 5 hours. So if we plug in that 5 for h, we're going to have c is equal to 5 times 5 plus 3. The 5 times 5 is 25, so c is equal to 25 plus 3 gives us a total of $28. For this number 4, it tells us that a plumber charges $25 for a service call plus $50 per hour of service. So we have a starting fee of $25 plus the $50 per hour, so that's 50 times h, going to give us our total cost. We're writing an equation in slope-intercept form for the cost C after h hours of service. That is this. And it then asks us what will be the total cost after 8 hours of work and then after 10 hours of work. So if we plug in 8 hours, we're going to have C is equal to 50 times 8 plus 25. That 50 times 8 is 400 plus 25 gives us a total cost of $425. For 10 hours of work, we can plug that in for h. So we would have C is equal to 50 times 10 plus 25. That 50 times 10 is 500. So that's 500 plus 25, which is going to give us a total of $525. For the next part of our lesson, we're looking at whether or not given graphs are functions. By testing these graphs with the vertical line test, you can tell whether or not you have a function. So if you draw a vertical line through any point on that graph, if it only intersects once, you have a function. If it intersects more than once, it's not a function. So if we look here at some examples that are done for us, if you look at the graph on the left, you have that vertical line test, and it only goes through that function once, so in fact, it is a function. However, if you look at the graph on the right, that line has a vertical line through it, and it intersects in 2 points, one here and one here. So that is not a function. You'll realize with these, when it's not a function, your a values, your x values, are the same. So that means that when you have something that that's not a function, your x values are repeating. So in any of these, if your x values repeat, you do not have a function. If we look at these graphs here, for example A, you have that vertical line through them. It intersects more than once, so this one is not a function. For example, B, if you did that vertical line through any point on this graph, and if it was straight, it would only intersect once. So this one is a function. Same thing with C. If at any point you drew that vertical line through the line that's already there, the blue line, you have a function because it only intersects once. And then with D, you have that vertical line that intersects 3 times, so this one is not a function. You have something also where you have different types of equations that represent functions. If you have something like f of x is equal to x squared, that is a function. Your x values will not repeat. Think about it. If you plug in a 1, you're going to get something. If you plug in a 2, you're going to get something. If you plug in a 3, you're going to get something. You can't plug in a 1 and get 2 different y values or outcomes from that. You can't plug in a 2 and get 2 different y values for that. Other rules when you are dealing with functions and looking at equations. Each element x in a set has exactly one element y. So your x values cannot repeat. When you are using points, no x can be repeated with a different y value. With your equations, your y value cannot be raised to an even power or inside the absolute value bars. Look at some examples. We're asked if the equation defines y as a function of x. So do we have functions here? For example, A, you have y is equal to y minus x squared is equal to 2. Even if you took this and solved it for y, you're going to have to add that x squared to both sides, and you get y is equal to x squared plus 2. Y is not inside the absolute value bars, and it's not raised to an even power, so this is a function. For B, we have x squared plus y squared is equal to 4. Because that y has a power that's even, this one is not a function. For C, we're given the absolute value of x plus 3 plus 2y is equal to 0. So even if you wanted to solve this for y, we can subtract the 2y from each side. So we have the absolute value of x plus 3 is equal to negative 2y. We can divide each side by that negative 2 and get that y is equal to the absolute value of x plus 3 all over negative 2. This y is not in the absolute value bars and is not raised to an even power, so this one is a function. And then for D, we have 3y squared minus 2x is equal to 9. Automatically, this y is raised to an even power, so this one is not a function. For E, you have the absolute value of x plus y is equal to negative 16. Because this y is inside the absolute value bars, again, this is not a function. The next part of your lesson just gives you more examples of functions. So if you see here, we have two different functions. If we look at these graphs, the one on the left is definitely a function because it only intersects once. That vertical line only intersects once, so this one is a function. However, this circle that you have on their coordinate plane, it intersects twice. You see that the equation of this has a y squared. That y is raised to an even power, so automatically it's not a function. Linear functions, you have straight lines. So you'll see these as either slope intercept form or y is equal to a number. You can also see it as f of x is equal to a number. You also will see x is equal to a number for that vertical line through your x-axis at a value. You also have power functions. So when n is when your x value is raised to a power, your square functions look like that u. Those cubic functions look like that sideways s. Your power of 4 functions look like your squared functions, and same thing with your so what you see here, any even power, it's going to be that u. Any odd power, you're going to have that sideways s looking line. For root functions, if you have the index, that's an even number, so the square root, the fourth root, the sixth root, the eighth root, so on. You're only going to have part of this S looking line. So it's only going to be that one side. If you have the odd root functions, so the cube root, the fifth root, the seventh root, the ninth root, so on, you're going to have the full line of that S. Reciprocal functions, when you have 1 over x squared, 1 over x cubed, 1 over x fourth, so on, will look like these. So if you have an odd power, you're going to have the top right hand, which is your first quadrant, and the bottom left hand, so your third quadrant lines. Any ones that are raised to a positive power in the denominator then will be the first and the second quadrant that you'll see those lines in. And lastly, you have your absolute value function, which is looking like a V, and your greatest integer function. You'll see these more like this. F of x is equal to a bracket with a bracket of x, like this. Okay.